Hey Pre-Calc, section 2.2, lesson 2, coming at you. These are all about circles and semicircles. Ooh. So before, what we did was we graphed equations in which we just plugged in x values, we got y values. We plotted points. We found x-intercepts, we found y-intercepts. Today I'm going to give you sort of a structure to look at in which you can create equations for circles and graph equations of circles based on this structure. So here's the structure. If you recall, you know what, I'm just going to throw it at you. Okay. So, right up there, this represents sort of like your standard equation for a circle, in which H represents the horizontal shifting that's occurring, K represents the vertical shifting that's occurring, and the R represents the radius of the circle. So just to show you how this kind of manifests itself in a particular problem, go to number 27 from page 102. So number 27 states that we've got the equation x plus 3 squared plus y minus 2 squared equals 9. So what does all this mean? Well, the horizontal shift is always opposite inside the parentheses. So if it said x minus 3, that means my center of my circle would go 3 units right. Since it's x plus 3, it's kind of like you've got an x minus negative 3 situation in which negative 3 is the horizontal shift. You're going left 3. So if your circle is originally centered around 0, 0, it's going left 3 up k units, up 2 units. So there's the center of my circle now. The center of my circle is at negative 3, 2. Usually you use the letter C to denote the center of a circle. Okay. Now, the radius is basically the distance from the center to any endpoint on the circle. So 3 units out, 3 units up, 3 units left, 3 units down. That would give us, I think, enough information to move that. If you guys had a compass, one of those things where you can just go around with those 3 units, you'd get a perfect circle. I don't have one of those compasses with the markers, so I'm just going to freehand it. Okay. That's all we had to do. Sketch the graph of the circle. Boom. There it is. So something that maybe could throw you guys off a little bit, I don't know, 25 looks a little iffy. The reason why 25 looks iffy is it's just x squared plus y squared equals 11. It seems to be lacking some of the structure that this has. But if you think about it, this is basically saying you're not shifting at all left or right. It's like x minus 0 squared. Yeah? And the same thing with the up or down. If there's no minus k, it's sort of like, oh, you're subtracting 0 from it. So 0, 0 is going to be the center of this circle. All right? And then the radius is squared in a circular equation like this. So something squared gives me 11. Root 11 squared is what gives me 11. So my radius is actually square root 11. I could plug that into a calculator, but I also know that root 9 is 3, root 16 is 4. So if I got between 3 and 4, closer to 3, I could probably estimate that it's like, what, 3.2, 3.3, 3.4? But let's be exact. Let's see here. Root 11 is 3.316. So go 3.3-ish right, 3.3-ish up, left, down. We no longer need the center. It's actually not a point on the circle. It's just, it's what grounds us. And there's our circle. All right, so we did 25. We looked at 27. Yeah, 31 looks like a kind of a weird situation. You got 4x squared plus 4y squared equals 1. Now we need to manipulate this in such a way that it looks like a clean number in front of our x squared. Clean number in front of our y squared. The radius doesn't seem to have too many restrictions. So here's what we can do. If I divide everybody on the left-hand side by 4 and everybody on the right by 4, that's going to get rid of these coefficients. So 4x squared over 4 is 1x squared. 4y squared over 4 is 1y squared equals a fourth. We're talking about 0, 0 as the centerpiece to this thing. And then you can ask yourself, if r squared is equal to a quarter, what would the radius be? Well, you can square root both sides. The square root of 1 is 1, square root of 4 is 2. It's a half. All right? And you don't need to put plus or minus because a radius is a length. Don't really talk about lengths in terms of negative. Yeah, in terms of negative lengths. So you'd go half a unit out, half a unit up, half a unit left, and half a unit down. It's just a little guy. All right. So those are your circles. Now what happens when we start talking about a semicircle? Well, a semicircle is basically a manipulation of this formula to get x by itself or y by itself. Let me show you what I mean by that. So let's say I just decided that I wanted to solve for y in this equation right here. What would I do to solve for y? Well, I can't just square root everybody and say, that square is gone, that square is gone, and that square is gone. It doesn't really work like that. You can't just square root both sides if there's a plus in between these two perfect squares. So I would have to subtract this entire quantity from both sides first. So x minus h squared minus x minus h squared zeroes itself out. Y minus k squared equals r squared minus x minus h squared. All right, now that I've got this particular perfect square by itself, I can square root the left and square root the right. Now, I was just talking about how radiuses, they don't have a plus or minus when you square root them. But if I'm talking about an x and a y value that lives in the xy plane in which x can go left or right, y can go up or down, and I square rooted both sides of an equation with variables, I actually need to take into consideration that y minus k could be the positive root r squared minus x minus h squared, which would be a semicircle above the x-axis, or it could be a negative root r squared minus x minus a squared, which would be a semicircle existing below the x-axis. And if you did this, then a semicircle would have a vertical shift k units on the outside of the root. Okay? So if I solve for y, this is technically the standard form for any semicircle. That would be a semicircle like this above the x-axis or a semicircle like this below the x-axis. So this is either above / below x-axis, depending on which of these signs you choose. Now, what about the ones where the semicircle could be this semicircle, or a semicircle that would exist to the right of the y-axis? Well, that would require us to get x by itself instead of y by itself. And if you got x by itself instead of y by itself, it's pretty much the same process. I'm just going to subtract the y minus k squared from both sides. So it's r squared minus y minus k squared. Then I'm going to square root both sides. Add h to both sides. So the positive, the positive version right here is going to be right of the y-axis with the radius in there, with the vertical shift inside, the horizontal shift on the outside, and then the negative, when x is by itself, is going to be what shows up as a semicircle to the left of the x-axis. So, right of y-axis, left of y-axis. Above the x-axis, below the x-axis. So we can do 33 and 35 now and make pretty good sense of what's going on. Let's check it out. 33 shows this equation. Which instantly tells you it's in terms of y, so we're talking about either above or below. There's a negative in front of the root, which means it's below the x-axis. All right, now we can determine the horizontal and vertical shift by what's going on inside here. It just says x squared. If you look over here, x minus 0 squared would match that. So it's not shifting left or right, and there's no plus k, which means the semicircle is centered around 0, 0. Now what's the radius? R squared is 16. So the square root of 16 is 4. It's got a radius of 4. And lives below the y-axis. Below the x-axis. Ta-da! Now what is the 35? What's different about that is it gives you x equals root 9 minus y squared. So that means we're talking about in terms of x by itself, yeah? That means it's positive, it's right of the y-axis. It's got a similarly centered around 0, 0 situation with a radius of 3 this time. So it's right of the y-axis. Centered around 0, 0. So you'd go 3 out, 3 up, 3 down, and it's this part of the circle. Seems like a good stopping point. I'll start back up and talk about how you can write equations of circles in that standard form that's above us.